Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. The Moon, Earth's celestial companion. A luminous legacy. The moon in mythology and culture. The moon has cast its luminous spell on humanity, leaving an indelible mark on our society. Its mesmerizing glow, captivating phases, and constant presence in the night sky have woven it into the fabric of our myths, legends, and cultural narratives. From the ancient Egyptians associating it with the god Thoth, the embodiment of wisdom and writing, to the Chinese moon goddess Chang'e, eternally banished to the moon after stealing an elixir of immortality, various cultures have attributed celestial powers and symbolic meanings to this enigmatic orb. The moon's rhythmic dance through the night sky has served as a natural timekeeper for millennia. Ancient civilizations used its phases to measure months and years, guiding their agricultural practices and shaping the rhythm of their lives. From the Islamic calendar, which uses lunar cycles to determine religious holidays, to the harvest festivals celebrated under the full moon's glow, the moon continues to hold cultural significance across the globe. The moon's captivating beauty has endlessly inspired artists, writers, and poets throughout history. Countless works of art, from the evocative paintings of J.M.W. Turner capturing the moon's ethereal luminescence to the poignant poems of William Butler Yeats lamenting the transience of life under its watchful gaze, showcase the enduring influence of the moon on human creativity. Even today, the moon continues to serve as a potent muse, inspiring artists and dreamers alike to reach for the stars. A geological marvel. Unveiling the lunar landscape. The moon is a world sculpted by a dynamic interplay of volcanic eruptions, meteorite impacts, and billions of years of space weathering. Stepping onto its surface is to step back in time, as the moon's unforgiving environment has preserved a record of its violent past. The dominant feature of the lunar landscape is the vast array of craters, formed by the collision of asteroids and comets with the moon's surface. These craters, ranging in size from microscopic pits to colossal basins, serve as silent witnesses to the moon's bombardment throughout its history. Studying these craters allows scientists to reconstruct the timeline of impact events and gain valuable insights into the composition of objects hurtling through the solar system. Beyond the stark beauty of the craters, vast plains of lunar mare, solidified lava flows, stretch across the moon's surface. These mare regions, formed billions of years ago when volcanic activity dominated the lunar interior, offer clues about the moon's internal composition and its early geological processes. Analyzing the composition of the mare basalts, the volcanic rock of the lunar plains, can reveal the chemical makeup of the moon's mantle and provide insights into the processes that shaped its early evolution. The lunar landscape also boasts towering mountains, some exceeding the heights of their terrestrial counterparts. However, due to the moon's lower gravity, these lunar mountains are formed differently than those on Earth. While Earth's mountains are often the result of plate tectonics, the lunar mountains are primarily the product of volcanic activity and the collapse of impact basins. Exploring these lunar peaks, particularly those in permanently shadowed regions, could hold the key to uncovering hidden ice deposits and revealing further details about the Moon's geological history. A world of contrasts. The lunar environment. While Earth and the Moon may appear as celestial companions, their environments are vastly different. The most striking disparity lies in the presence of a significant atmosphere on Earth and its stark absence on the Moon. This lack of atmosphere on the Moon has profound consequences, creating a world of extreme temperature variations and relentless solar radiation. Under the direct gaze of the Sun, the lunar surface can reach a scorching 127 degrees Celsius (260 degrees Fahrenheit), hot enough to boil water. However, in the absence of an atmosphere to trap heat, temperatures plummet to a bone-chilling -173 degrees Celsius (-280 degrees Fahrenheit) in the shadows of craters and during the lunar night. This drastic swing in temperature, exceeding 400 degrees Celsius, poses a significant challenge for any potential future human presence on the Moon. Extensive technological advancements and robust insulation strategies would be necessary to mitigate these extreme temperature variations and create habitable environments for astronauts. Furthermore, the Moon's weak gravitational pull, roughly 1/6th that of Earth, creates a unique environment. Objects on the Moon weigh significantly less than they do on Earth, and individuals would experience a sensation of lightness, akin to floating, when moving around. This lower gravity also impacts the trajectory of objects, requiring adjustments to how humans and machines would move and operate on the lunar surface. Understanding these contrasting environments is crucial for future lunar exploration and potential human habitation. Scientists and engineers are continuously developing strategies to overcome these challenges, paving the way for a future where humanity can establish a permanent presence on the Moon. A celestial detective. Clues to the Moon's formation. Unraveling the mystery of the Moon's formation is akin to solving a celestial detective story, piecing together the fragments of evidence left behind from billions of years ago. The leading theory, the giant impact hypothesis, proposes a dramatic collision as the origin story of our lunar companion. This theory posits that the Moon formed approximately 4.5 billion years ago when a celestial body, roughly the size of Mars, collided with the early Earth. The immense energy released from this collision is believed to have ejected a large portion of Earth's mantle material into orbit, eventually coalescing around Earth and forming the Moon. Intriguing evidence supporting this theory lies in the remarkable similarities between the isotopic composition of lunar and Earth rocks. Isotopes are different forms of an element with varying numbers of neutrons in their nuclei. The fact that the ratios of these isotopes are nearly identical in lunar and Earth rocks suggests a shared origin for both celestial bodies. Additionally, the Moon's lack of a significant iron core, unlike Earth, aligns with the theory that the impacting body stripped away the heavier elements during the collision. Further exploration and analysis of lunar samples hold the key to unlocking more definitive answers about the Moon's formation. Missions like the Apollo program and future endeavors like the Artemis program aim to collect lunar rock and soil samples for detailed analysis in sophisticated laboratories on Earth. By studying the composition, age, and geological features of these samples, Scientists hope to piece together the timeline of events leading to the Moon's creation and gain a deeper understanding of the early history of the Earth-Moon system. The water mystery. Searching for lunar ice. Traditionally, the Moon was thought to be devoid of water, a barren and airless world. However, recent discoveries have challenged this notion, hinting at the presence of water ice in permanently shadowed craters near the lunar poles. These areas, perpetually shrouded in darkness, never receive sunlight and offer potential locations for ice deposits to remain stable over long periods. The first concrete evidence for lunar ice came in 1994 when data from the Clementine spacecraft suggested the presence of water ice in permanently shadowed craters. Subsequent missions, like the Lunar Prospector and Lacrosse, further confirmed these findings, detecting specific signatures of water molecules on the lunar surface. The presence of lunar ice raises fascinating questions and opens exciting possibilities. It could offer valuable insights into the volatile composition of the early solar system and the delivery of water to planets and moons. Additionally, lunar water ice could be a valuable resource for future settlements and scientific endeavors on the Moon. Extracting water ice could provide a source of drinking water for astronauts, as well as the potential to generate oxygen and fuel through various technological processes. However, extracting and utilizing lunar ice would require overcoming significant technical challenges. The harsh lunar environment, coupled with the logistical hurdles of accessing and processing ice deposits, necessitates innovative solutions and long-term planning. A geological treasure trove. Lunar resources and future exploration. The Moon is not just a celestial marvel. It also holds the potential for valuable resources that could be crucial for future exploration and potential colonization. These resources fall into two main categories: in situ resources and extracted resources. In situ resources are materials found naturally on the Moon and utilized directly, without the need for extensive processing. The most prominent example is lunar water ice, as discussed in the previous section. Additionally, the lunar regolith, the loose and unconsolidated surface layer, contains various minerals like silicon, aluminum, and iron. These elements could be used for construction purposes, potentially facilitating the development of lunar habitats and infrastructure. Extracted resources, on the other hand, involve processing lunar materials to extract specific elements or compounds. Helium-3, a rare isotope of helium, is one such potential resource. This isotope holds promise as a future fuel source for fusion reactors, offering a potentially clean and abundant energy source compared to traditional methods. However, extracting and utilizing helium-3 is still in its early stages of development and requires significant technological advancements. The exploration and potential utilization of lunar resources raise important ethical considerations. Responsible resource extraction practices are crucial to minimize the environmental impact on the Moon and ensure the preservation of its scientific and cultural value. Additionally, international collaboration and clear regulations would be necessary to ensure the responsible and equitable utilization of lunar resources for the benefit of all humankind. As we continue to explore the Moon, the potential for resource utilization becomes an increasingly relevant aspect of future lunar endeavors. By striking a balance between scientific exploration, resource development, and ethical considerations, we can pave the way for a sustainable and collaborative future on our celestial companion. A stepping stone. The Moon and beyond. The Moon serves as a crucial stepping stone for humanity's journey into the solar system. Establishing a sustained human presence on the Moon offers invaluable experience and knowledge for future exploration endeavors. This lunar base could serve multifaceted purposes, acting as a scientific research outpost, a training ground for astronauts, and a potential refueling station for deep space exploration missions. As a scientific research outpost, the Moon presents a unique platform for studying various astronomical phenomena. The lunar surface is relatively free from the interference of Earth's atmosphere, allowing for clearer observations of the cosmos. Additionally, the Moon itself holds scientific value, offering insights into the formation and evolution of planetary bodies. Studying lunar samples and geological features can provide valuable clues about the early history of the Earth-Moon system and the processes that shaped planets and moons throughout the solar system. Furthermore, establishing a lunar base would serve as a critical training ground for astronauts venturing further into space. The lunar environment, with its lower gravity and unique challenges, provides a realistic training ground for astronauts to experience the complexities of living and working in space. These experiences can be invaluable for preparing them for the physical and psychological demands of future missions to Mars and beyond. Moreover, the Moon's potential as a refueling station for deep space exploration is another crucial aspect. Water ice on the Moon, if efficiently extracted and processed, could be converted into hydrogen and oxygen, the propellants for rockets. This would eliminate the need to transport these essential fuels from Earth, significantly reducing the cost and complexity of deep space missions. In conclusion, establishing a lunar base goes beyond simply planting a flag on another celestial body. It represents a critical step in humanity's journey of exploration and scientific discovery. The knowledge and experience gained from this endeavor will pave the way for future endeavors, allowing us to reach for the stars with increased capability and confidence. A collaborative future. International cooperation and the Moon. Exploring the Moon is not a solitary endeavor. It necessitates international collaboration and the combined expertise of nations across the globe. The Moon holds the potential to benefit all of humanity, fostering scientific advancement, technological innovation, and the peaceful exploration of space. Several international treaties, such as the Outer Space Treaty, establish the framework for peaceful and cooperative exploration of space. These treaties emphasize the non-militarization of space and the importance of sharing scientific discoveries for the benefit of all humankind. Collaborative efforts like the Artemis program, led by the United States with the participation of various space agencies, showcase the power of international cooperation. By pooling resources and expertise, nations can achieve ambitious lunar exploration goals, accelerating scientific discovery and technological advancements while fostering a sense of global unity in pushing the boundaries of human exploration. Furthermore, international collaboration promotes peaceful competition, encouraging nations to invest in innovative technologies and spacefaring capabilities. This healthy competition ultimately benefits all parties involved, driving scientific progress and fostering a collaborative environment for the exploration and utilization of space resources. As we continue to explore the Moon, international cooperation will remain paramount. By working together, nations can ensure the responsible and equitable utilization of lunar resources, prioritize scientific discovery, and foster a spirit of global collaboration as we venture further into the vast expanse of space. Mission Artemis: A New Dawn in Lunar Exploration. After the groundbreaking Apollo missions, a new chapter in lunar exploration unfolds with the ambitious Artemis program. Led by the United States in collaboration with international partners, Artemis seeks to not only land the first woman and the first person of color on the Moon but also establish a sustainable human presence there, fostering a vibrant future beyond Earth's cradle. Building upon the successes and invaluable lessons learned from previous lunar endeavors, the Artemis program is meticulously planned, encompassing a series of missions strategically designed to achieve its long-term goals. Artemis 1, launched in November 2022, marked a significant milestone by successfully testing the Orion spacecraft and the Space Launch System, SLS, the most powerful rocket ever built. This uncrewed mission served as a crucial stepping stone, paving the way for future crewed missions that will carry humanity back to the lunar surface. Artemis 2, targeted for launch in 2025, will be the program's first crewed mission. A team of astronauts will embark on a lunar flyby, circling the Moon in a pivotal test of the Orion spacecraft's capabilities with a crew on board in a lunar environment. Subsequent Artemis missions will meticulously focus on building the essential infrastructure for a lunar base camp, a long-term human habitation project on the Moon. This includes Artemis 3, targeted for 2025/2026, aiming to land the first woman and person of color on the lunar surface near the South Pole. This historic landing will be followed by the establishment of Artemis Base Camp, marking a new era of sustained human presence beyond Earth. The Artemis program transcends the mere goal of landing humans on the Moon. It serves as a pivotal launchpad for future endeavors, propelling humanity further into the vast expanse of space. The lessons learned and technologies developed during the program will be invaluable for future missions to Mars and beyond, serving as stepping stones on this ambitious journey of exploration. One of the most significant aspects of Artemis lies in the development of cutting-edge technologies. The program has spurred the creation of the Orion spacecraft, a sophisticated vehicle designed for deep space exploration, and the SLS rocket, currently the most powerful operational launch vehicle in the world. These advancements not only enable lunar exploration but also possess the potential to be adapted and further developed for future deep space missions, pushing the boundaries of human reach and capability. Furthermore, the Artemis program fosters international collaboration, fostering a spirit of unity and shared purpose among various space agencies worldwide. This collaborative effort allows for the pooling of expertise, resources, and diverse perspectives, significantly accelerating the pace of scientific discovery and technological innovation. By working together, nations can achieve ambitious goals that would be beyond the reach of any single entity, fostering a sense of global unity as we venture further into the cosmos. Beyond the technological advancements and international collaboration, the Moon itself holds immense scientific value. Studying lunar samples and geological features can provide invaluable insights into the formation of our solar system, offering a window into the early history of the Earth and potentially unveiling clues about the existence of resources that could be crucial for sustaining future human presence on the lunar surface. Additionally, the potential for extracting resources like water ice and minerals from the Moon opens doors for further scientific research and the development of sustainable systems for future deep space exploration. In conclusion, the Artemis program transcends its immediate goals, representing a paradigm shift in human space exploration. It serves as a testament to the power of international collaboration, technological innovation, and the enduring human spirit of exploration. As we venture further into the cosmos, the Artemis program paves the way for a future where humanity establishes a permanent presence on the Moon, pushing the boundaries of scientific discovery and setting our sights on the vast and beckoning expanse of the universe.